Hey trigonometry class, this is your lesson on section 3.1. We're going to be looking at something called radian measures. So far we've been doing everything in degrees in your calculator. I've been telling you put in degree mode over and over, but this time we're going to be having a chance of putting our calculators in radians. And so the first thing we're going to be doing is what is a radian measure, and then we're going to look at converting between degrees and radians, and then we're going to find function values for angles that are in radians. So let's get started. Alright, so here's what the definition of a radian is. An angle with its vertex at the center of a circle that intercepts an arc on the circle equal in length to the radius of the circle has a measure of 1 radian. So right here, drawn, this right here is our radius, and 1 radian on a circle, this circle is, this arc right here is equal to the same thing as what your radius is. So we call this angle measurement 1 radian. Okay, so let's look at something else. To convert between degrees and radians, this is how you do it. So if you're given a degree measurement and you're converting it to radians, then what you do is multiply a degree measure by this right here, pi over 180, and that's usually degrees. And then simplify to convert it to radians. If you want to convert back to degrees, if you have a radian measure, what you do is multiply the radian measure by 180 degrees over pi, and then simplify to convert it to degrees. Let's look at an example. Alright, so here we're asked to convert each degree measure to radians. So what I said before, we are going to multiply this by pi over 180 degrees, and then we're going to simplify this. So this is like saying 108 degrees pi over 180. Well, this 108 over 180 simplifies, so simplify that as much as possible, not in decimal form, but the 108 over 180 simplifies to 3/5. So we're just going to tag on this pi right here and say 3 pi over 5. And we're done. That is in radians. You can either just leave it as is, or you can actually just say radians on the end like this. If your degree or your radian measure doesn't have anything written on it, either radians or the little degree symbol, it's understood always to be in radians, even if you don't have this thing tagged on the end of it right there. Okay, so that right there is 3 pi over 5 radians. That's a radian measure. That's the same thing as 108 degrees. All right, let's look at this one. Again, multiply by pi over 180 degrees. That was a terrible pi. Let's do that. Okay. Now, simplify this. So 135 divided by 180, well, that simplifies to 3/4. So negative 3 pi over 4. And we're done. On this one, we're going to, since it's in decimal degrees, we are going to put it in decimal radians. We are going to multiply the pi, 3.14, throughout your decimal number here. So the simple way to do this next one is just plug it straight away into your calculator. Plug in 325.7 degrees times pi over 180 degrees, and then hit equals or enter on your calculator, and you will get approximately 5.685 radians. And that's it for converting each degree measure into radians. Now let's look at converting the other way. So this example, we are converting radian measures to degrees. And this time what we do is, instead of multiplying by pi over 180, it's the reciprocal. Multiply by 180 degrees over pi. So this is where our pi's end up canceling out with each other. And then we multiply 11/12 times 180, and we get 165 degrees. Now, make sure you put degrees on something when it's a degree measurement. Otherwise, I will understand that you meant radians, and you will get counted off. All right, so the next one, I did not mean to write an equal sign. Okay. Let's multiply this to convert it to degrees. 180 over pi. Okay, again, pi's end up canceling. Now multiply the -76 times 180. That ends up giving you -210 degrees. And now on this one, we're going to, again, multiply by 180 degrees over pi. And we can leave this in decimal degrees. We don't have any pi's to cancel out, so you just need to plug all of this into your calculator. And what you'll end up getting, see what the calculator gets, is this right here. 167.3 degrees. Or you can actually convert this to degrees, minutes, seconds. And degrees, minutes, seconds gets me this right here. -167 degrees and 18 minutes. And we're done with converting radian measures to degrees. Okay, this is what I've stated before whenever we're converting degrees to radians and back and forth. I said if no unit of angle measure is specified, then the angle is understood to be measured in radians. Okay, same thing goes for your book. If you don't see a degree symbol, then it's understood to be radians. Here's just a little spreadsheet here that shows us, here's the degrees, like the special degrees that we have covered so far. 0 degrees, it's the same thing in radians, 0 radians. And then 30 degrees, if we convert to radians, that is pi over 6. And the approximation of that is right here. And then you can keep going for any degree measurement, but here's a few right here. Now this is going to be very useful on your exams and quizzes that you have. I will let you use this unit circle right here to help you in figuring out values for your function values, for your trigonometric function values. Like if I say find what is sine of pi over 6, well, your unit circle that I will give you will actually give you what this value is over here on our circle, what point that is. So I'll go over the unit circle with you tomorrow in class, and each of these will actually have values for where they lie on this circle. Now, this is our last example. What I'm going to have you do is find each function value, just like we have found the function value for, say, cosine of 30 degrees or tangent of 45 degrees. You've learned how to find those values before in class. So how I'm going to show you how to find these values with radian measures being used instead of degrees is we're just going to convert to degrees for now. So this right here, cosine of 5 pi over 6, well, if you convert that to degrees, let's go back to our unit circle. 5 pi over 6, oh, it's right here. That's 150 degrees. So what we're trying to find here is cosine 150 degrees And notice cosine is negative in that second quadrant. The reference angle to cosine, let's go back here. The reference angle to cosine would be right here. It's 30 degrees. So cosine of 30 is square root of 3 over 2. So this is going to be negative square root 3 over 2. And that's our solution on this one. Now let's go to cotangent. Alright, I'm going to go back to that unit circle and we're going to find the degree measure for this, or you can use your calculator, your brain to figure out what degree measure is 3 pi over 4 radians. 3 pi over 4 radians right here, 135 degrees. So cotangent of 135 degrees. Now, cotangent, go through the steps of finding the reference angle. You know what quadrant this is in. It's in the second quadrant. Cotangent is going to be negative. So this is actually going to equal negative 1. Okay. Because this is actually reference angle of 45 degrees. And cotangent of 45 is 1, but it's in the second quadrant, like I said. So you put a negative on it. Now secant, let's look at 5 pi over 3. Let's look for that. 5 pi over here, 5 pi over 3. That's 300 degrees. So let's replace that. Okay, its reference angle is 60. So we're looking for secant of 60 degrees, and secant in the fourth quadrant is actually going to be positive. So, and if you use your chart, you should know secant of 60 is 2. And that's it for figuring out function values for these. Instead of having degrees, we have radian measures. And it works out just the same if we convert it back to degrees. Alright, so yeah, there you go. That's the end of what I have for you. And I will see y'all in class tomorrow, and we will look at the unit circle a little bit more. Goodbye, everybody.